All right. Think we're good to go. This is series in parallel. Okay, and Screencastify had a little bit of an update, so all the stuff is just kind of weird. Like my image of me here is widescreen now instead of being full screen. Okay, well, we're going to talk quickly about this section on series and parallel. Okay, series and parallel, two types of circuits that you can encounter in this class. Okay. You'll encounter both of them. You need to know how they work and how they operate. Okay, so when we say that elements are in series with each other, it's connected in such a way, okay, that charges flow out one element and into another. Okay, so you start with one element, right? This is basically that they continue out one element into another, right? There's no junction between elements. Okay. You could also say this is like in a line. Okay. It's like, you can think of it like a TV series you're supposed to watch. You're supposed to go from episode 1 to episode 2 to episode 3 to episode 4 to episode 5, right? You're not supposed to bounce around, right? You're supposed to watch it in one. In other words, charges have no choice. Okay? So charges have to follow the path. They cannot diverge from it whatsoever. But parallel means that it's connected in a way that we would call maybe like side to side. Okay. So if this means that elements are connected parallel side by side, and this means that charges have an exclusive choice. Okay, so basically what this means is that when elements are connected in parallel, charges reach what's called a junction. It's like a fork in the road where they have to make a choice. They're either going to go down one path or they're going to go down the other, right? They have to go down one or the other. They have to choose one, but in choosing one of them, it will exclude the other option. Okay, so in this circuit, we would say that A and C are in parallel. Okay, because you see that A and C are connected side by side. Okay, we can say that B and the battery are in series. Okay, because you notice there's no junction between the battery and B, right? There is a connection between the battery and B that does not include a junction in it at all. Okay. Okay. In this other circuit, okay, you can say that A and B are in series with each other, right? Meanwhile, C and the battery are parallel. Okay? So C and the battery are parallel to each other because there's a junction between them, but A and B, there's no junction between them, therefore they are in series with each other. Okay? Talking about these switches, right? So how a switch works, right, is it controls the flow of the charges. It typically makes it to where, if the switch is closed, right, if it's closed, that means that it's connected and charges can flow through. But if it's open, then that means that the charges cannot flow through. They are unable to do so. Okay, so in this case, we have a circuit where the battery and A are in series with each other. So the charges, when they go, they're going to go out the battery and then through A, and they're going to get here, and they're either going to choose the B branch or C. If the switch is closed, okay, then they can go either B or C. But if the switch is open, they can't go down this path because there's no way through for them. So instead, they're going to all go towards B, okay? Normally, If the switch is closed, right, they could pick either one. But if the switch is open, it's almost like this branch doesn't even exist, right? So if the switch is open, this branch doesn't even really exist because there's no way to get through to the end from here, right? So if the switch is open, this branch is out, okay? And you would say that A and B are in series with each other. Okay? Then, if the switch is closed, then this branch is active. You can actually, the charges can actually flow through it now, okay? But that actually renders B and C now in parallel. Okay? So it keeps that branch alive, right? And then you can go through that, okay? And then the final part here, down here on this, just on this page, is just describing the circuit, right? Okay, the circuit on the left here, there's a series connection between the battery and A. Okay, A and battery are in series. Okay. Meanwhile, B, C, and D are parallel. Okay. Why are they in parallel? You're looking at me like, wait, that doesn't make any sense because the C is diagonal, right? This is just another way of representing a circuit that might look like this. Okay. Here's A. Okay. There's B. There's C. And there's D. Okay. This is just another way of representing that circuit, right? Don't freak out too much about seeing this because this is, I mean, this is a confusing way to represent it, but this right here is really what you want to, you know, is what you should translate this into. You don't always have to draw it, but sometimes it may help, right? Okay, and then talking about the other circuit, okay, if we're talking about this second circuit here, we can say that the battery and A, battery, the little r here, and A in series, okay? And B is in parallel with the C and D branch, right? Because there's a junction right here, right? So B would be in parallel with C and D. So B parallel to C and D branch, okay? Okay. I'm not going to talk about these build a circuit things because we would actually have to build the circuits. So you should notice that when you add a bunch of light bulbs in series with each other, they get dimmer. Okay. Meanwhile, if you build them in parallel, they all stay if you add a bunch of light bulbs in series, you should notice that the first one is probably going to be the brightest. Meanwhile, there's going to be less and less light as it goes. Meanwhile, in parallel, it should be the same across all of them, though it may continue to, though the brightness may change when you add light bulbs to it. Okay, if we're finding the equivalent resistance of something, okay, then what we're doing is we're basically combining the resistors, and we're trying to figure out how many ohms could we place in lieu of all the resistors that we've got, right? Find number of ohms that, if connected in place of resistors, acts the same way. Okay? So if we're trying to find equivalent resistance, we're basically taking all of our resistors and we're combining them in such a way that we can figure out if we were to take every resistor in a circuit and replace it with a single resistor, we want to figure out what would be the resistance of that resistor such that it will cause the circuit to act the same way. Okay, it doesn't mean that it'll function the same way necessarily, right? I can't take all the light bulbs in my classroom and combine them into one massive light bulb that blinds you. Okay, it doesn't necessarily mean it'll function exactly the same way. Okay. Now, in series, finding equivalent resistance is simple. You just got to do R sub S equals R1 plus R2 plus R3 plus yada, 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 plus, the nth resistor. And when I say the nth resistor, I mean you keep going through every resistor that's in series and you keep adding them all up, okay? Meanwhile, if you are trying to find the meanwhile, if you're trying to find equivalent resistance of things that are in parallel with each other, you would have to use this weird funky equation, which is 1 over Rp, that's equivalent resistance in parallel, is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus yada 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 plus 1 over R to the nth, okay? Or R, the nth R, okay? Okay. So those are the two formulas. I think you need to memorize them. I don't remember if they're given to you on the formula sheet, but you should memorize them anyway, just because they're important laws. Okay, find the equivalent resistance of each of these. So these are multi-step problems here, okay? If you're trying to figure out the equivalent resistance of, let's say, this left circuit, okay, you've got a ton of resistors here, but I always like to start furthest away from the battery. So our battery is over here on the left side, so I'm going to start on the right side, okay? Notice on the right side, we've got resistors that are in series with each other. We've got the 15 ohm is in series with the 10, is in series with the 15, right? Okay, so what I'm going to do is I'm going to take these sets of this set of resistors. These are all in series, okay? And so we're just going to add them all together because they're resistors in series. We can just add them together directly. So 15 plus 10 plus 15, and that should give you 40 ohms. 40 ohms, okay? So we've turned this circuit already into a brand new circuit that looks like this, okay? All right. Okay, we've turned it into a brand new circuit that looks like this: 10 ohms, 12 ohms, 10 ohms, and this one we solved is 40 ohms. Okay, we've turned it into this brand new circuit. Now what we can recognize, again, working furthest from the battery, we've got these two resistors are in parallel from each other. So when we're solving, right, it's important to keep in mind that the formula I gave you, right, if you do 1 over the resistor plus 1 over resistor plus 1 over resistor, remember, that gives you the inverse of what you're looking for. So you would have to then raise it all to the -1 power to actually get your solution. So we would do parentheses 1 over 10 plus 1 over 40, and then raise that to the -1st power to get a new resistance of 8 ohms, okay? That turns our circuit now effectively into this, okay? 10, 8, 10 ohms, 8 ohms, oh gosh, 8 ohms, and then 12 ohms. Okay, that turns our circuit now into this. And now look at that. Everything is in series with each other. It's all beautiful. It's all nice. We can clean it all up really easily, right? So it's all in series. Boom. All we have to do now, 10 plus 8 plus 12, that should give you 30 ohms. Okay, and so we've effectively resolved this complicated circuit into a circuit that's literally just this. Okay. That's literally all we've done, okay? Okay, for the second example, don't get too freaked out, right? This says A and B. Where's the battery, right? Doesn't matter. You can pretend that the battery is somewhere between A and B. There's other stuff going on, but we don't care about it, okay? We just want to resolve everything here into a single resistor, okay? And we can do that. So we're going to start out furthest from the battery, okay? Let's pretend that the battery's, at the bottom. So we're going to start furthest from the battery, okay? First and foremost, the easiest thing to do is going to be to resolve this right here because they're in parallel, okay? And we'll do 1 over 60 plus 1 over 90, and then to the -1st power to get a 36 ohms, okay? So now we can rewrite this as being, this is A, boom, boom, here's B, okay, and then there's one resistor in here at the bottom, okay, 25 ohms, 48 ohms, 36 ohms, and then 16 ohms, Okay, there you go. That's what you got to do, right? Okay, now all that you have to do is recognize, okay, well, these two, these branches are in parallel from each other, but we can't really do much until we've got one resistor in each branch. So let's go ahead and add these together, because look at that. They're all in series. How beautiful. Okay, so they're in series. Okay, so we just got to do 48 plus 36 plus 16, and that should give us 100 ohms. Okay. So now we've resolved this into a very simple circuit. Boom. Boom. Okay. So this is just 25 ohms, and then this is 100 ohms. Okay. Now it's just parallel. All we have to do now is just apply our parallel rule for resistors. Okay. Ooh, I don't want to use that color because it's too bright. It's hard to see. Okay. So parallel. Okay. That's going to be 1 over 100 plus 1 over 25. That gives you negative 1, or to the negative first power. That should give you about 20 ohms. Okay. Beautiful. So this is effectively saying that this circuit can be equal to just this. Okay. Which is kind of crazy to think about, right? Okay. There's two more problems here, right? What we can do on the left one is on the left set, it's going to look a little bit. It's going to look a little weird, right? Because now we've got two things on the side. We've got two separate. It goes into branches, and it's almost like two separate circuits, right? So we can kind of solve them simultaneously. Well, first I want you to recognize that 10 and 20 are in series with each other. Okay. They're in series with each other, so we would do 10 plus 20 to get 30 ohms, okay? Another thing that we can do right off the bat is recognize that these two are in parallel with each other, okay? They're in parallel with each other, so we get 1 over 50 plus 1 over 200 to the negative first power, and that should give you about 40 ohms, okay? Okay, so now we've resolved this circuit into a brand new, wonderful circuit that will look something like this. Okay, still have that. Great. And then here. Okay, and then here. Okay, so we've got 30 ohms, we've got 80 ohms, and we've got 40 ohms, okay? Okay, now we can then continue through, and we can see these are in series with each other, okay? Okay, so if they're in series with each other, all we gotta do is add them up. 80 plus 40, that gives you 120 ohms, okay? 120 ohms. Okay. Now we should be able to get a new circuit that looks kind of like this. Okay. 120 ohms and 30 ohms. Okay. Now these two are in parallel with each other because there is a branch between them, or sorry, a junction between them, right? So then we end up getting something that looks kind of like this, okay? All right, those two are in parallel with each other. So we get 1 over 30, and let me put my parentheses, plus 1 over 120. Let me put my negative 1 in the exponent, and that should give you an equivalent resistance of 24 ohms, okay? Okay, the next example shows another circuit segment, okay? Again, remember, it doesn't matter what happens between A and B. We don't really care. But we just want to resolve this into a single resistor. The first step of action is going to be take these parallel resistors and get them together, okay? So take your parallel resistors and add them together. 1 over 20 plus 1 over 30 plus 1 over 60, okay? And we do all that to the negative first power, okay? You should get 10 ohms in doing that. So now we've got A, 10 ohms, 15 ohms, okay. And 100 ohms. Boom. Okay. Should recognize now we've got two resistors in series with each other. Okay. So it's series. Okay. And we do 10 plus 15. That gives you 25 ohms. Okay. So now you should end up with a new circuit. It looks like this. Okay. Boom. Boom. This is still 100 ohms. This is now 25 ohms. Okay. And then you should hopefully, obviously, understand these two are now in parallel with each other. So now all you have to do is just do 1 over 25 plus 1 over 100 is negative 1. Okay. Negative 1. And that will give you 20 ohms. Okay. All right. There you go. That's series versus parallel. All right. Have fun.